Okay, all right. So plan for this video is for us to make it all the way through the remaining parts, 15 through 20. And uh, they're not necessarily in order of difficulty, but we will do them in order just so it's easier to find. So we're already up through 14. Let's do a new sheet and edit this. Come on now. Edit sheet, call it 15. And base view. And let's put the meeting up on the other one. Why not? Part 15, 16, 17, 18. Yeah, okay, so we got the rest. And I'll be doing mine so that you can read them better. We'll put R3 there. And let's join. Okay. So what was our method? Okay, our first method is center marks for arcs and circles and centerline bisectors for holes from the side, and then we dimension everything. Okay, so let's annotate. Let's get our center mark tool, and this gets a center mark, and this. Let's bring everything a little bit closer. So we can zoom in. Oh my God. And okay, center mark. This is a center mark. There's an arc there. This one and this one, you can see there's a slight difference. Okay, click on that one. Kind of weird to get the dot out there. It must be just such a small scale. Okay, and I think that's it for curved surfaces. It does look like there's a lot, but it's really only that. Now, centerline bisector. Okay, this hole right here, when you're looking at it from the front, looks like this. So that gets a hole, or same thing here. Okay, and these two are these holes looking from the side. So they get one, they get one. This is the main hole going through from the side. And these. All right, so let's start dimensioning. We can start dimensioning with the curved surfaces or the curved edges, and then we'll do our width left to right and other linear dimensions, whatever is needed from that point. So we definitely need an arc for that and a curve there, or a diameter for that. This arc right here, that's probably better than this. And if you move your mouse out and you get that, you kind of just have to go through the center point in order to get there. Those are all those curved surfaces. There are two arcs that are exactly the same here, which means we can do the TYP thing here. Okay, and same thing for the diameter of this hole. We'll go TYP. And those are all the curved surfaces. Now let's just think about locations of things. Okay, normally we would start on the left, and every time something happens, take a dimension, except we already get that amount from that radius, so we don't need to start there. We can start from the center point. We know the distance from the center point here is that same thing as that. So how about from here to here? That's probably a good one. And then from here to here. starting to think that the top view is probably the better one for these. It's the top one. Hard to say. Again, the point is to make sure that you have all of the dimensions you need and then find the best place for it. Can we get total width from this? I like the idea of the distance working from this. I guess this is all right because it's now we're just using this right side hole as our starting point. It's a little different, but I think we can get to every dimension from this, every width dimension. Very unsatisfying, but I think that works. Okay, height, down to up. First thing that happens is the height of this right here. Second thing that happens is the height of the center point. Third thing that happens is the height of this center point, but now we're crossing a ton of extension lines. So let's put that over here. This is already getting a little ridiculous. See, anytime this is going on, that's probably not ideal. I don't know. Yeah, like I said, this isn't very satisfying. What if we went through this and made sure we had every dimension that we had on when we made it? Okay, so let's try this a different way. Let's make a new sheet. Let's just go back, start over. We can keep the curve dimensions because we know we need those. All right, let's see what dimensions we actually needed to make the part. Okay, so we needed the height, total width, and then the length of the extrusion. So let's get those dimension, or the height of the base. So we need the height, the width, and I'm going to put it outside just to keep things out of the way. Total height, total width, and total depth. It should be something like this. Okay, then what else do we need? We needed these fillets for the curve, so we've got that with the one thing. Then we have holes. Holes need size and location. So we have the size, we just need the location, the distance from the left side in, the distance from the back there, the distance from the back to there. And it's still getting kind of out of control. Whoa, I didn't know you could do that. Why are we doing this, folks? Come on. Okay, we have total, there we go. And distance from the front is just this plus this. And this is typical for left and right, so that works. So we have that. Next extrusion, we needed the size of the base, which is going to be This thickness was how far it was extruded that way. And the 4 was that, but it's really just that twice. Then how far did we extrude it? We extruded it this far. Okay, so there's that. So this is another way. Then we have the rounded off top, which we have, the hole, which we have, and this curve, which we have. So really, that's it. That's just another way of solving that. You can see as the reason why we have these rules is because it quickly gets out of hand. You know, this is only a medium complex part, but you know, it's already getting super crowded on the page there. Yeah, so there's that. All right, so let's close this. I think that's probably the hardest one just because it's a lot of asymmetry. Close that. And we'll go back to this one, make a new sheet. Let's call this part 16. And let's base view part 16. All right, another difficult one. All right, let's trust the process. Curved surfaces, or rather, arcs and diameters, arcs and circles, radius and diameters. And I think that's it. And some centerline bisectors from the top. This is a center line. Even though it makes a weird cross there with the other hidden line, it is what it is. And then from the front, there's this and that. And this is the 2 holes from the side. Okay, and a lot of this is height. So I'm going to start with height dimensions. I just feel I can't explain why specifically, but starting at the bottom, every time something that happens, take a dimension. And I forgot to do curved surfaces, arcs and radius. So this one is the same as this other sort of shoulder. So we can give it a TYP. Then there is this and this. And then on the top, we have this, and that's the same as the other side. So we'll give that a TYP. And same thing over here. TYP. That's all of the curved surfaces. Height, we've got the height of this ledge, the height of the center point of this arc, and the height of the center point of our top feature. Oh, this one needs a centerline bisector as well. This is that hole going the other direction. And we can get total height based off of this plus that top circle. Okay, so that was height. Let's do width. We can use the center points of the 2 circles to do width because we know the total width is just that 5 plus this arc. And need to know the width of, I mean, could we work backwards from that? I think that's actually enough information. Because the width of this top portion is really just the diameter of the rounded face. And do we know that it's centered? I guess we don't know that it's centered. But I would want to put the center point of that to dimension the location of the center point, which you could do either on the front view or the top view. On the top view, it would be to a hidden line. So we'll do it on the front view. Distance from here to a known point, like the side of everything. I think that's it for width. And then depth front to back. We know the distance from the front to this center point, so we can just use that. We can start from the back, do that from there to there, there to there. And that shows us the location of the center point. It doesn't show us the depth of this, so we can just put that there. I think that's it. I mean, like I said, these are pretty complex, and it does take a lot of inference to make sure that you have all of the dimensions that you need in order to build it. But I think that's enough. Yeah, there we go, part 16. All right, and then, so the next three, much easier by a long shot. Assuming my computer doesn't crash. Wow, really? Okay. And let's go ahead and new sheet. We'll call this sheet 17. Base view, part 17. And I still don't know why the complexities go out of order, but that's fine. Annotate and center marks. What are things that look curved? That looks curved. Wow, unfortunate that this is over here, but that is curved. There isn't really a way to, when we dimension to this arc, it's going to be a hidden line. There isn't a way to get it where it's visible because it's on the left side. That's really strange. And we don't have any holes for the no center line bisectors. Let's just go through this. Okay. We have one curved surface here, which we can give a radius of 4, and another one here, radius of 2. That's it for curved surfaces, left to right. Every time something happens, first thing that happens is that. The next thing that happens is this, but this is really just the edge of this, so it's not even really a thing. So there's that. That's it for width. Okay, height. The first thing that happens is the height of this, but this is just the where the curve ends, so we don't even need that. So the only other height is total height. And then depth front to back. The first thing that happens is this, but this is that edge of the circle or the edge of the semicircle. And you always want to dimension to a center point. So there's that tells you where that is. And as long as we know total depth, we'll be fine. And which is the distance from there to there, but it's getting kind of crowded up here. Let's just put it over here. Distance from there to there. And I think that's enough for that one. And wow, I wonder what is stressing my computer out. Okie dokie. And let's do another one. What was that? 17. Let's do 18. It's a little more complex than the last two. And circle or center mark, center and arc. That's a curved part. And that's it for that. And center line bisectors, we have one hole, one complete hole. So that gets a center line. And it's the same hole as this from the side. There we go. And let's dimension our curve stuff. The radius of there is 4, diameter of that is 4. And you can't use TYP for those because those are not the same thing. These two at the top, however, are like literally the same thing. So we can do TYP. And that's it for curved surfaces. Now let's work left to right. Because we have this arc here, we know the distance from the side to there. So we can start with this center mark as our sort of origin point. First thing that happens is the edge of this. Good. The next thing that happens is the center mark, but I'd rather have the center mark go where it looks like a circle. So we'll come back to that. The next thing that happens is this, and the only other width is this, but not to forget about the center mark. Width-wise, let's put that here. Although we already have this, so whenever you have a repeated dimension, try to figure out whether or not it actually is a needed dimension. Okay, so that's width. Height-wise, first thing that happens is this ledge, but on the right side view, it goes to a contour. You can actually see like an edge of the shape rather than just an interior line, so we'll keep it there. The next thing that happens is the height of the center point, which definitely better on the front view because that's where the height of the center mark is rather than the center line bisector. And the only other height is total height, which is the height of the center point plus the radius of this arc. Then depth front to back, we can, do we know this to be that? I guess we know that lines up, not sure. So I suppose we can just sort of include that from the center mark. Let's go front to back. First thing that or back, let's go back to front since there's all this mess up there. That could go there, but over here on the right, it goes to a contour. Then from the back to the center mark is the next thing that happens. And then total depth is just the distance to that center mark plus the our TYP radius. And I'm pretty sure that is enough. So let's save it. Wait 10 minutes for it to save. Did I not change the? So this part, which part is this? 18. I forgot to rename this. And new sheet, base view, part 19. And let's do some curved surfaces there. And actually, if you notice, when I clicked on that, it didn't do the full circle. That's because this click right here is clicking on this part of the circle. And this click right here is clicking on this part of the circle. So they aren't really the same, although you do need both of them for the front view. And that's the only view that has a curved surface. So this is strange. Because when I go to click this, it's going to give me radius of 2, which is confusing because it is a full circle. Yeah, we'll live with it. And so let's do location of the center point. Distance from the bottom to there is that. And that's height of that. And we can also do total height here. I'm just doing height first to sort of get some of that out of the way because there's going to be a lot of width dimensions. Width-wise, left to right, first thing that happens is that. The next thing that happens is the center point of the circle. And the only other width, oh no, the other width is this edge right here. But this edge is this. So we'll put that one there. And there. And then depth front to back. There's a more contour on the top view, so we'll do that to that and that to that. And there you go, part 19. And one more, it should be pretty easy. Yeah. And saved. And saved. Here we go. 1, 2, 3, saved. Hey, it worked. Okay. So let's do a new sheet. I also didn't name this one. The previous one was 19. And this one is 20. And base view, part 20. And annotate center points. The only curved surface we have is that. Excellent. And let's bring it in a little tighter here. Okay, dimensions. We kind of do this regular, left to right. First thing that happens from the left is that. Next thing that happens from the left is that. The only thing that happens width-wise is total width. Height, first thing that happens is this, but this is just a function of the radius of this cutaway, which we need, and total height, which is what we need, and we can get rid of this one. And the only other feature that we need to deal with height-wise is the vertical location, either distance from the top to here or the distance from the bottom to here, to show how big that cutaway is. And that's everything that happens height-wise. It's kind of weird that that points to that. Maybe I'll move it a little bit so it's clear it doesn't point to this hidden line and confuse somebody. And then depth-wise, front to back, the first thing that happens is this point, but this is just a function of total width minus the radius of this cut. And so we really just need total depth, which can go either top view or right side view. And that's it. Okay, so save it, yes to all. And remember, the way you're going to hand it in, you need to export as a PDF, but you have to switch it to all sheets. So it comes out as one, as one PDF with all of the sheets on a single file, a single PDF file. And I'm pretty sure that I've limited the file types that you can upload to the assignment to PDF, because you cannot hand in inventor files. I literally cannot open your inventor files. So it's file, export as a PDF, and then switch options, make sure you switch it to all sheets. save it somewhere you know, and then hand in that file. All right. That's it for number parts. Let me know if you have any questions.